Hey everyone, welcome back to another episode of Coronavirus Chemistry. Today we are going to be learning about dilutions, and dilutions are pretty straightforward. If you have a solution like this is a potassium permanganate solution, has a really nice vibrant purple color. You can dilute it down, and that makes sense obviously. If you have a glass of soda or something like that, you add a bunch of water to it, no longer does it taste very good because you have diluted it down. This is the same idea here, so potassium permanganate, I could dilute it down. Let's just go ahead and change its color and hopefully it'll work. So how do you make a solution diluted? Pretty straightforward too. You add just a bunch of water to it. Grab a bunch of water here and add water. Uh-oh. You can see that my solution is starting to lighten up. Okay, so it used to be pretty dark purple, and now it is kind of a light purple. And that's because I diluted it. And if we go back in the video, you can see it's quite a bit less concentrated now. I've added a lot more water to it, and that reduces its concentration. It reduces its molarity. It was kind of a dark purple, and now it's sort of a light bluey purple color, which is kind of neat. So I've diluted it down, and the dilution equation is really easy. I love it. It's very, very easy to remember. Here it is. It is M1 times V1 equals M2 times V2. And the variables mean this. So the first solution's molarity is M1 in molar units, so moles per liter. And then the original solution's volume is V1, and it actually doesn't matter whether it's in liters or milliliters or any volume unit at all, as long as you have the same unit on both sides, because they're going to cancel out. So it doesn't really matter. And then on the other side of the equation, or the side of the equal sign, is the molarity of the second diluted solution, M2. So after you diluted it, what is the diluted solution's molarity? And that's multiplied by the diluted solution's volume in milliliters or liters or whatever. So let's go ahead and use this equation. Wipe off some water, because that's just what happens when you're doing this off the fly. There we go. So if you dilute a 1.6 molar lithium chloride solution with a volume of 175 by adding 825 milliliters of water, what is its new molarity? Okay, so again, we're going to use that M1 times V1 equals M2 times V2 equation. And in this problem, they're saying, okay, I've got a solution. Okay, I've got some kind of solution. I'm going to draw a picture. I'll use green. Oops. And it's 175 mils. Okay, 175. It doesn't matter if it's lithium chloride, sodium chloride, sugar. Doesn't matter. That has no effect on the calculation. And then somebody goes ahead and adds a whole bunch of water. So they're going to add in 825 milliliters of water. So the solvent is water, and we're going to add in 825 milliliters of water. And they want to know, well, after adding that 825 milliliters of water, what is the concentration of this lithium chloride solution? So M1 V1 equals M2 V2. We're told all the variables ultimately except M2. We want to know the solution's concentration after that much water has been added. So M1 in this case is going to be 1.6 molar. And then V1, that's the solution's volume at the beginning. It has a volume of 175 milliliters. I'll keep it in milliliters, just keep things simple. And then I don't know M2. And then I'm not really told directly what the volume of the new solution is, but I am told how much the solution originally was and how much water was added. So that's going to be 175 plus 825. Okay, and if you do the math there, that is 1,000. So I'll rewrite it. So 1.6 times 175 equals M2 times 1,000. 1,000 milliliters, this is molar, this is milliliters, this is milliliters. So to find M2, it's just a simple algebra problem there. Divide by 1,000 on both sides, so M2 is equal to, and then we can do that on our calculator. So 1.6 times 175 divided by 1,000 equals 0.28. So the solution's volume after adding all that water is 0.28 molar. And that's it. That's dilution, really. Let me do one more problem with that. Kind of messed up with writing this one, but I think you get the idea. How many milliliters of a 5 molar copper sulfate solution must be added to 160 milliliters of water to make a 0.3 molar copper sulfate solution? Okay, so in this question, they're asking us really, okay, I've got this really concentrated 5 molar solution that's really, really concentrated, and I want to make a new solution that has a volume of 160 milliliters at a concentration of 0.3 molars. And I need to use this original solution to make that. So in this problem, you're going to be asked, really, how much of the original solution do I need? Original. So we're still going to use M1 V1 equals M2 V2, but really you're going to be finding that. You're going to be finding V1. How much of the original concentrated stock solution do you need to make this new solution that has a much lower concentration? So we're told that the original solution has a molarity of 5 molar. We don't know how much we need of that original solution, but we know that the new solution is going to be 0.3 molar. And then we also know that we need to make this solution have a volume of 160 milliliters plus what we add to it. So we're going to be adding 160 milliliters and then whatever we need of the original solution to make the diluted solution. So what I'm going to put in here is this. I'm going to put in 160 for that 160 milliliters of water I want to add, and then I'm also going to add in V1. Yeah, kind of weird. So this is how much I need of the original solution on both sides of the equation. So it's a little bit of algebra here. So let's go ahead and do that. So 5 V1 equals, and that's going to be 0.3 times 160. So 0.3 times 160, 48. 48 going to be cross multiply. What is that, FOIL? I don't remember. But we're going to be distributing. That's the word I'm looking for. I'm going to distribute to each of those terms in the parentheses. And then so it's going to be 0.3 V1. And let's go ahead and get everything that we want on one side. So minus 0.3 V1 on both sides. So that's going to be 5 times 0.3 would be 4.7 V1 equals 48. Okay, and then we're going to solve for V1. So V1 is going to be 48 divided by 4.7, and I get 10.2. Let's go ahead and do 10.2. There we go. There's our answer. That's how many milliliters of the original solution I need to use to add to 160 milliliters of water, which makes the solution 0.3 molar. A little bit of a complicated problem, but at the same time very much something you might do in a chemistry lab. You want to make something with a certain volume and a certain concentration, and you got to use an original solution which is very concentrated. We do that quite a bit in lab. And that's dilutions. I'm actually going to stop right there with this video. I'm going to make another video in just a moment with stoichiometry, and we're going to use that. I'll set this up right now, where we use stoichiometry and solutions to determine how much stuff is being made of a product, and then also precipitation. So we're making, remember all those things where we mix them together and we get a solid that sits at the bottom of the cup. We're going to talk about that in the stoichiometry with that in just a moment, so stay tuned.